Good afternoon, Dave Kenworthy. It's the 23rd of the 8th, 2021. And I've just been absolutely stunned by what this spreadsheet has just shown me. Because I've introduced Shusi into it. And what we find is that when the digit is the root 2 calculation, the Shusi's 10 pi. Now, I'm not sure I've ever heard that from anybody, but that's what happens. And the reason it happens is because we're using 20 root 2 for the Cubit. So if we multiply that by 10 over 9, we're effectively multiplying root 2 by 20 over 9. And that is pi. So this is an amazing spreadsheet, and it's one I've put together to show that this idea that there's one key qubit that gives the answer to everything at Giza is just not. It's not on. Because there's loads and loads of different methods of arriving at qubits. And the basic one is the geodetic qubit base 100 that we've talked about, and it's this one here. And we know that that's, I'll put it in here, it's 50,000 divided by 176, so there it is. And what I'm doing is I'm multiplying this column here, which is B, that's B10, multiplying it by 0.733, which is the base 100 digit. We're getting the base 100 qubit there. Now, there's a big anomaly in Jim's findings with this Shusi, because when he's producing his Earth circumference, it's this one here. Let's just expand that a little bit. It's this one, 248579545. Now, when we use 20.625 as the qubit, we get this for the Earth circumference, which is not the same, even though that is designed using the Egyptian digit. Here, I'm not using the Egyptian digit, I'm only using the base 100 digit, and we can still get 20.625 with it. And what we can do here is we can go through and find, because we're using this 0.733, and we know there are 36666.666 R inches in the Giza base, we can start using this knowledge to give us the qubits in digits. So we've already got that one, and we can get this root 2 version 1 qubit, and this is using 198 over 7 as 20 root 2. So that goes there, that's 198 over 7. And then we multiply it by 733, and we get this qubit. And look at what happens with the Shusi. It's just stunning. I mean, you multiply that by 10 over 9 and you get 10 pi as 22 over 7. I nearly fell off my chair when I saw that. And we get this for the Earth's circumference, 24891.4286, produced by that version of pi, when we know we're also getting that one with the same version of pi. So that is really quite something. And then we're going down, we've got another version of pi here, and that version of pi, well, if we divide by 10, it's pi, and if we square that, we get 800 over 91. I've already been through the mathematics of this. So I'm very familiar with this. And that is the Earth's circumference that you get. And this one is using 2800 divided by 99 as 20 root 2. And that's that. And we get this qubit here, and that's the qubit that Jacob Boas told me about. So those are the number of digits in it. Those are the number of digits in the 198/7 cubit, and that's the length of the cubit. And I'm familiar with that, giving that Earth circumference. And we look at the Earth circumference, it's very simply the cubit times 1200. Cubit times 1200, all the way down. And all these cubits, we know these from Berryman, and we know these down here from Berryman. I've written Berryman. There's a couple there that I'm not sure of, but the killer cubit here for me is this Michel and Neil. Because I put it in as what it is, 20.736, and then I divide it by 0.733 and get this number. And then I multiply that by 10/9 and we get this, and this cannot be wrong because 33.14181818 is the version of pi that goes with this. And now we know why, and nobody ever knew why, but now we do. And the Earth circumference is this, was spot on. And what I've done here with these columns is imperial feet down here for the Earth's circumference. And that is 132,000,000 less this number every time. And then I'm turning it into barleycorns dividing it by 3.66. Just because it was producing some interesting numbers like that one, that one, that one, and that one, 432, divided by 12 is 360. So we can see there that there's something going on when we use barleycorns. It's not strictly correct to do that, but it's definitely strictly correct to use miles. And this first root 2 version 1 cubit is creating, from this difference, 108.571 miles. That's the actual root 2, and that's root 2 as 140/99. And this is the one that I'm saying is absolutely deliberate, that it gives 111.111 miles difference from 25,000 miles, which is just incredible. And this is the unit that I discussed with Jacob Boas a long time ago on the Graham Hancock website. So I know that is Petrie's second determination at the Giza base, and that's where it's coming from. And that's the version of pi that's working with it. That's the length of the cubit, that's the Earth's circumference, and that's the number of feet in the Earth's circumference. That's the difference in feet. And then I've used the barleycorn column, and then I've used the genuine miles. And look at all these differences that we're getting down here. They're all significant meteorological numbers. So let's go back and see what we've got, because there's some incredible stuff going on here. The next one is the shorter geodetic, and it's this one divided by 1760 multiplied by 1750. I've called it the shorter geodetic one, and it's producing this amount here, and it's producing Jim's numbers, the shorter geodetic cubit. There it is, 131250000 for the Earth's circumference. It's a completely different way of calculating it, and it's calculated using the 0.7333 base 100 digit. So this is just showing us that there's loads and loads of different ways to get to these numbers. There's nothing set in stone. The people that designed these systems were so flexible in the way they approach the use of number. And the next one is even more stunning, because this is the base 99 geodetic cubit, which has given us 20.625. And look what's happening here. I got this number from Rods. Rods was using this for a long time, and I started playing around with it because I just wondered why it kept cropping up all the time in her calculations. And look at what it's given us as a Shusi. I did get mixed up with that. 3.125 Babylonian pi. set with 20.625. We've already discussed this. So that's not unexpected. But it's just showing us that we're bang on the money with this interpretation here. Then we go on to the qubit I've called the expected qubit, which is 28 digits. It's giving us that for pi, which we're disappearing off the pi scale now. 28 digits, 20.5333, Earth circumference in miles, 24640. So we're 360 there off 25,000 miles. Again, that is totally deliberate, isn't it? The system gives us that, and they knew what they were doing. Everything about this system is just superbly structured. Then we go on to the Babylonian qubit. The reason why is because 1,000... Oops, forgot the plus again. Divided by 36. That's the Babylonian qubit, because it's 1,000 divided by 36, and that is Babylonian metrology. We know it is. We know the Babylonians had a unit of 1,000 divided by 360. They were using 360 all over the place. And that gives Shusi of... Well, it's not such a good number there. Excuse me. So, we're looking at 24,444.444 miles, and we're 555.555. Absolutely deliberate again. The Sumerian qubit, 19.8. It's 27 digits, 30 sushi. Exactly what Jim's telling us. He's got it spot on. No mistakes. And this is verification of what Jim's telling us. And then I've put the unexpected qubit because nobody expects 25 units in a qubit. And look at the Shusi. It's the same cross-fertilization. 25 digits, 18.333 inches for that particular qubit. And again, dead deliberate. The Earth circumference is 22,000 miles. And the difference in miles is 3,000 from 25,000. And look at it in barleycorns, 432, another Earth circumference number. So the whole thing has produced this unexpected reconciliation of pi here. And I dropped this one in, not expecting anything to happen, and it produces this. It's absolutely fabulous stuff, and I'm going to stop it here, but I'm been really, really happy about this today. So thank you very much for listening. Cheers.